So we have defined the electromagnetic potentials A and V through these equations. B is equal to curl of A and E is equal to gradient of V minus del A del T. Okay, and we have studied a very crucial property of these potentials. The property is that absolute values of these potentials V and A in these equations are not unique, corresponding to the electric field E and the magnetic field B. Okay, we can take any arbitrary values of V and A. That means here we can take any arbitrary values of A and V, and they will all satisfy or represent the same electric field E and the same magnetic field B. Let us discuss something more about this property. Actually, we are aware of this kind of property of potentials. For example, let us consider the electric field and the electric potential in electrostatics. Okay, so let us consider the electric field E between two points P and Q. Okay, suppose the potentials at these points are V1 and V2. Then we know that the strength or intensity of this electric field between these 2 points will depend on the potential difference, that is V1 minus V2. Okay, now suppose we change the potentials to some other values, say V1 to V3 and V2 to V4. Okay, and suppose we have kept the potential difference remains same, that means V3 minus, we have kept V3 minus V4 is equal to V1 minus V2. Okay, then what will happen to this electric field? We know that this electric field will not change under this change of these potentials, since the electric field only depends on the potential difference. The electric field does not depend on the absolute values of the potentials at these points. Okay, and that means we already know about this property of electric potential, that the electric field between two points does not depend on the absolute value of the potentials at these points. Rather, the electric field will depend only on the potential difference. Okay, that means we can take any arbitrary value of the potentials at a given point. Okay, and it will not have any effect on the physical field. Okay, so this is the important point we have to note down, that the absolute value of the potential has nothing to do with the physical field. We can take any arbitrary value of the potential and it has no effect on the physical field. So from this example, now it is clear that here in this present discussion about the electromagnetic potentials, we are trying to understand the same property as we have just seen in case of electric potential and electric field. Okay, that means we are trying to understand the same property of these electromagnetic potentials, that these potentials corresponding to this electric field E and magnetic field are not unique. We can take any arbitrary values of these potentials and it will have no effect on this physical field E and B. That means we can take any arbitrary values of these potentials and all of them will represent the same electric field and the same magnetic field. Here we have another example of gravitational potential energy, from which we can also realize about the arbitrariness of potential energy. However, this example has no direct connection to electrodynamics, but regarding the concept of potential energy, it is same whether it is gravitational potential energy or say electrostatic potential energy. Okay. So what we know about this system is that we choose the gravitational potential energy as 0 on the Earth's surface, and we define the potential energy at height h as V is equal to mg h. Okay. But we also know that we can have also some non-zero value of potential energy on the Earth's surface, which can be shown from some other calculations. Okay. And if we choose some non-zero value, say V naught on Earth's surface, then accordingly the potential energy at this point will also change to V is equal to V naught plus mg h. Okay. So that the potential difference between these 2 points will remain same as mg h. That means the potential energy at height h will remain same as mg h. So what we can see from this example is that there is arbitrariness in the choice of this potential energy. That means we can choose the potential energy on Earth's surface as V is equal to 0 or as well as some other non-zero value, say V naught. Okay. That means whatever absolute value of these potentials we choose, it will not affect the physical problem. That means the potential energy at height h will always remain same as mg h. That means the choice of this absolute value of the potential has no effect on the physical gravitational field. We can choose any arbitrary value of the potential energy and the gravitational physical field will remain same, it will not change. Thus we have seen that we actually know about this crucial property of electromagnetic potentials, that the potentials are absolute value of the potentials are not unique. We can take any arbitrary value of the potentials for a given field. Okay. And this piece of knowledge we actually know from our conventional physics. In other words, we can say that we have reformulated this concept of potential energy about their arbitrariness in the theory of electrodynamics in an advanced way. Finally, let us make one thing clear, that instead of saying separate electric field E and separate magnetic field B, let us call them collectively as electromagnetic field, as we are studying them in the theory of electrodynamics. Okay, and these fields are always coupled, and we can also see it from these expressions. Although it seems that the vector potential A is connected to magnetic field B separately, but from this expression we can see that actually both the potentials V and A are coupled. Okay, they are coupled to the same electric field E. Okay, that means these potentials are coupled mathematically, and thereby the fields are also coupled. Okay, so instead of saying electromagnetic potentials V and A corresponding to a given E and a separate given B, we will say that electromagnetic potentials V and A corresponding to a given electromagnetic field, that means E plus B. Further, instead of saying potentials V and A are not unique corresponding to E and B, we will say that potentials V and A are not unique to a given electromagnetic field. That means these potentials A and V in these equations are not unique corresponding to a given electromagnetic field. We can take any arbitrary values of them and they will all represent the same electromagnetic field.